Hey, today we are going to be adding and subtracting polynomials. So we're going to be on pages 13 and 14. Okay. So we're just going to go back to the basics and we're just going to practice adding and subtracting to start off with our simplifying of polynomials or many term things. So a polynomial expression can always be added or subtracted. In order to visualize what happens when two polynomials are combined, we're just going to create a model. This is probably the only time we'll actually create a model just to kind of see and visualize this, okay? We're going to use algebra tiles. And since this is an ed puzzle, we'll just kind of draw them. So we're going to sketch a model with our first polynomial above and the second to find the sum. Then we're going to answer the questions. So first we're just going to create this problem, 2x squared plus 5x minus 3. So first I'm going to create 2x squared. So I'm going to make some x squareds. Okay. Now I'm going to create 5x bars. Okay, x, 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 x. Okay. And now I'm going to create 3 negative 1s. Okay, now I'm going to do the same thing, but I'm going to do it with this next problem. So we have x squared minus 2x plus 1. So I'm going to create 1x squared. Okay. I'm going to create 2 negative x bars. Okay. And then finally, I am going to create just a positive 1. Okay. Now I'm just going to combine them basically together. So I see 1, 2, 3 right here. So I have 3x squares. Okay. Then I see 5 x's, 2 negative x's. So that makes a 0 and that makes a 0. So I'm left with 3 x's. Okay. And then I have a 3 negative 1s and a positive 1. Right here would make a 0 and I'm left with 2 negative 1s. So I added them together and we get 3x squared, 3x bars, and 2 negative 1s. Okay, so describe what steps took place to add the polynomials. I just look for, I made them different colors or the same, I made them different colors, or you could look for the same shape, whatever makes the most sense to you. Any advantages? I think it's a very visual problem right here. Like we can see, okay, I'm going to put x squares together, bars together, and numbers together. Probably the disadvantage is that it takes a very long time to draw these pretty pictures. So we're going to talk about various ways to do this, okay? Adding polynomials. So polynomials can be added by identifying like terms, just like how we did like terms in 6th grade and 7th grade, and adding the coefficients of the like terms together. Describe how to identify like terms in the space below. Okay, so like terms would be like, okay, I'm putting my squares together, my x's together, and my numbers together. Okay, so I'm looking for common variables. Okay, oopsie. So if we have common variables, we can always put those together, and we can also just put regular constant numbers together as well. So that's how we kind of look for like terms. We're going to talk about two different ways. We're going to talk about two different ways to do this method. Okay, we have the horizontal method and we have the vertical method. Okay, using just different properties to do this. So I'm going to show you guys both ways. There is not a right or a wrong way to do this. Stop. Okay, we have 5x squared plus 4x minus 7. And we're going to add this trinomial to this other trinomial, which is negative 2x squared plus 3x minus 11. Okay, so this is one way of doing this, and this is using just the commutative property of addition, which means I can group different things together with adding. So I'm going to group the squares together. Okay, so I'm going to put 5x squared and negative 2x squared together. Okay, and 5 squares minus 2 squares would be 3x squares. Keep in mind, I'm not changing the exponent, excuse me. All I'm doing is changing the number of them. Okay. Next, I'm going to look for other common things. I see 4x's and 3x's. So I have 4x's, 3x's. That would be 7x's total. Okay. And then finally, I see -7 and -11. Those are my constant numbers. And I can always add just regular numbers together and get -18. Okay. So that is one way to do this problem. Okay. And that's just grouping with a commutative property and just grouping like terms together. Okay. Next, we have the vertical method. So the vertical method means just doing basically the same thing, but just looking at it vertically. So I'm going to write the first problem. Okay. And then here's my plus sign. And I'm going to put just these grouped together. So I'm going to do -2x squared. So I'm going to put that on top of it. Then I'm going to put 3x, be very intentional, and put it on top of the 4x. And then I'm going to put -11 intentionally on top of the -7. Okay. Then we could just, add like we know how to add from 3rd grade. 5 minus 2 is 3. 4 plus 3 is 7. And -7 plus -11 is -18. All right. I want you guys to go ahead and choose which method makes the most sense to you. There's not a right or a wrong answer, and just tell me why. Okay. Me personally, I go towards more of the horizontal method. I won't even actually like group them. I'll kind of just group them in my head. I kind of organize my brain this way, and I'll like draw different lines around them and just group them in my head and add them that way. But if the vertical method you like that works too. Add using whatever method you like. So go ahead and come up with your answer for this problem. All right, so whichever method you got, hopefully you came up with -8 and -1, making -9x squares. Okay, -6 and +9, making 3x's. And 1 and -7, making -6. So this would be simplified to -9x's plus 3x minus 6. You're annoying. All right, on to the next page. Now we're going to actually talk about subtracting polynomials. So subtracting is the same as adding the inverse or opposite. Okay, so back in the day when you learned subtraction, you could rewrite 15 minus 7. Rewriting that is 15 plus the opposite of 7, which is -7. So both of these get us the same answer, and you kind of just thought about it however you wanted to think about it. Subtracting is just like adding a negative. Okay? So when subtracting polynomials, we can rewrite the problems as an addition problem by adding the inverse or adding the opposite of each term in the second polynomial. Okay. So we're just going to practice this first. We have 8x plus 9. Okay. And we can change this subtraction problem to an addition problem by inversing everything in here. So we can inverse -10x and inverse -6 to a +6. Okay. Another way I think of it is kind of like distributing a negative. So we'll kind of do that for this one as well. So we have this first problem. Okay. And now what I'm going to do is I'm basically just going to distribute the negative to it. So a negative times a negative is a positive, 5x squared. Negative positive makes a -9x. -11, we become +11. Okay, so it's really just your preference and what makes the most sense for you. Okay, so we have these couple problems. And we're just going to kind of play it and try them. So 3x squared plus 9x minus 1 minus -4x squared plus 8x minus 6. So the first thing I'm going to do is I'm going to rewrite this. 3x squared plus 9x minus 1. Okay. You don't technically need to have the parentheses at this point since those were just to say, hey, this is this trinomial. And now we're going to subtract this trinomial. So we're going to subtract a -4x. So subtracting a negative is like adding. Subtracting a positive is like subtracting. And subtracting a negative is like adding. Okay. I highly recommend that you guys definitely at least rewrite it so you will make less mistakes that way. Okay, this isn't a very hard concept, but a lot of people will forget to distribute the negative to every single thing in the parentheses. Okay, now we just have to combine like terms. So we're going to start with the highest degree. So 3 and 4 squares make 7 squares, so 7x squared. Again, I'm not changing the exponent, I'm just changing the number that I have. 9x. Negative 8x would be 1x, and then negative 1 and positive 6 would make a positive 5. All right, so you guys are going to go ahead and try this one. All right, so hopefully we found the common terms. So 2x minus 3x squared plus 12 minus 9x squared plus 8, and then minus 4x. Keeping in mind that we're just combining things that we can combine together. The squares we can put together, negative 12x squared, 2x, negative 4x, and then 12 and 8. So we got negative 12x squared minus 2x plus 20. All right, this next one, we have a problem out in front. We're going to add this binomial, and then we're also going to subtract this binomial. So the first thing I like to do is get rid of the parentheses. So I'm going to first distribute or subtract this problem. Okay, so I'm going to subtract 8x. I'm also going to subtract 4. Okay. Now, I don't technically actually even need these parentheses right now because this adding doesn't really do anything. It just kind of groups them together. So I'm just going to group in my brain the squares together. So 4x plus a negative 3x squared would make up 1x squared. Okay. Then we have 5x with a negative 8x, and that would make negative 3x. Then finally, we have negative 4. Nothing can really be put with negative 4, so our final answer is x squared minus 3x minus 4. All right, this final one, you guys are going to go ahead and try. Okay, so we have this math problem plus this math problem, so this is really just combining like terms. So I'm going to put the squares together. 1/5 plus 3/5 is 4/5, so 4/5 x squared. Then 2/3 x can't be put with anything. And then negative 8 and positive 9 would make a positive 1. Okay. Katie simplified the expression as shown. Describe Katie's error and find and correct the simplified expression. So the way I like to do this one is just do it myself and kind of see and then pinpoint where a mistake happened. So first I see this problem minus 3 problems. So I'm going to rewrite this as 7x squared. Okay. I'm going to subtract a negative x squared. So that's like subtracting a negative is like adding. Okay. Subtracting a negative is like adding 7x. And then subtracting a 9, subtracting a 9. Okay. So first I'm just going to check and see if she has exactly what I have. And so I see right here, there is a mistake right there. Okay, so that was probably just subtracting, forgetting to subtract a negative is like adding. So now, obviously, if this is the error, this answer is going to be wrong. So we're going to come up with the right answer. I'm going to put the squares together and get 15x squared, 7x minus 9. All right. For this last problem, Matt's rectangular back patio has a total area of 12x squared minus 5x plus 1. The outdoor rug is represented by the white triangle and has an area of 8x squared plus 2x minus 4. Write an expression to represent the area of just the gray region, the area not covered by the rug. Okay, so we're going to get into like a lot of these weird shapes and stuff like that. And so I always kind of like to think about what is going on if it wasn't a weird problem. So let's just say I had a rectangle and I had a back patio that had an area that was 100. okay? Then if I have a rug that is 70, okay, the question's asking me is how much is not covered by the rug? Well, how would I figure out the extra? I would just subtract the two, okay? So guess what? This is the same exact concept, just with a more complex math problem. So this is the area of the rug. Okay. And this is the area of the rug, or excuse me, this is the area of the patio, and this is the area of the rug. And it's asking me how much is not being covered by the rug. So we have to find the difference between them, which means we have to subtract. Okay, so I'm going to subtract 8x squared. I'm going to subtract 2x. I'm going to subtract a negative 4, which is like adding 4. Okay, so I'm going to combine the squares together, 12x, negative 8x squared, which would be 4x squared. Okay. Negative 5x, negative 2x, which is negative 7x. And then 1 and 5, which would make 4. So the area that is grayed out that would not be covered by the rug would be this math problem. All right, for today, we are just going to do some delta math.